Hello everyone, welcome to the EA Global Summit 2023. This is Sangavi from EA Global Summit team. I'm happy to welcome you all to this virtual event where Sparx EA users from all over the world come together to learn, work and share their experiences. Whether you are an seasoned EA expert or just beginning your journey with Sparx EA, this summit has something special in store for each one of you. We have a fantastic lineup of prominent speakers or experts in the Sparx EA community and want to share their experiences with you. This talk will be by Anne van Roosmalen from EA Expertise, who will be shedding light on setting standards in the container industry. But remember that this event isn't just about presentations, but collaboration. Take advantage of networking opportunities and discuss with fellow attendees and the speaker after the session in Slack. If you haven't received a Slack invite or missed it, please check the chat box for the invite link. You may also drop your email ID in the chat box. Our team will add you in the discussion channel. Also, we encourage you to ask questions. You can do so in the Q&A window. The speaker will answer a few questions here at the end of the session and then connect with you directly in Slack. After the summit, our team will get in touch with you to hear your comments on the various sessions. If you have any feedback, we would love to hear them. Now, without further ado, I hand the virtual stage over to Anne van Roosmalen.
Thank you very much, Sangavi, for this nice introduction. My talk will be about the standards in the container industry, or setting standards in the container industry. And that's my talk. But before I start, I'd like to introduce myself. My name is Han van Roosmalen. I'm a partner at EA Expertise in the Netherlands. As EA Expertise, we do provide license support, training, and consultancy. And besides playing with Sparx all the time, I'm also a husband, a father of two sons, and I'm a sailor. And as you see in the picture, I will be sailing around the world with Team Halong Bay from Vietnam in the Clip Around the World race for this year and next year. The container industry is a huge industry. in this infographic, you'll see that there are more than 249 movements of containers in 2022. There are 471 ports where containers are transferred from ships to other means of transport, and there are a lot of vessels going, like almost 3,500. It's nice to know that about 80% of the global goods that are traded are transported overseas. In this infographic, you see that Maersk was one of the biggest ocean carriers, ships around 4.3 million standard containers a year. And if you stack them together in nice rows, you will find that you can hide the Eiffel Tower pretty much inside of it. It also has over 700 ships in its fleet. At the moment, I do consultancy for DCSA. DCSA is the Digital Container Shipping Association, which is a non-profit organization and is established in 2019. And its biggest stakeholders are the largest container shipping companies, as you see in this picture. And the purpose or the vision of DCSA is to make a digitally interconnected container shipping industry. And what does DCSA do? Well, it prepares all kinds of standards for the digital transformation in the area of containers handling. There are examples of those digital APIs that are available already, like the booking process, just-in-time port call, track and trace, and operating vessel schedules and IoT events. These are in development or already available on the internet and can be used by the stakeholders of DCSA to connect, for instance, shippers with carriers, share their information digitally. One of the most important APIs that are still that is being worked on is the electronic bill of lading, which will probably be ready in 2030. The first releases are available already, but you can imagine that when you want to have a digital data exchange with not only carriers, but also regulators, banks, insurers, and shippers, you have to do a lot of work. Why is this important? And that's because the container shipment is an environment where a lot of parties are involved. There are many carriers, many terminals, and most interestingly, each terminal and each carrier does the same processes, but in a different way. For some communication, EDI messages are used, but airmail, fax, and telex are also being used. And pictures in a PDF document sent by email is also part of a slowly coming digital transformation. How does DCSA do that? Together with stakeholders, they find an area in which the standards might contribute. And then they facilitate the congregation of the stakeholder groups to find a sweet spot. So on what area are we going to develop an API for? And then the design and development starts. And the design starts with analysis of the business process to get a better understanding of that part of the area that needs to be digitalized. Then we come up with a glossary of terms that can be understood by everybody. So it's very important that we use the right terms. So and put the right definitions to it so that everybody can understand what we are talking about, and that makes it easier. Find the interaction points between where the various parties will communicate. And then combine existing standards and definitions with the newly defined standard. If the standard is being set, then it will be reviewed and published, and test cases are provided. DCSA then will build a reference application that is based on these interaction patterns. So each stakeholder can make his own test systems or his systems test against the reference application. This is the way it works. The first step is try to map the processes into the industry blueprint. We make the industry blueprint, that's the main project that combines overview of all the processes within the industry. Then we design all the steps, and we use process diagrams, user stories, and data definitions for that. Then we create an interface standard, which is at the moment a document, and then the document will be transformed into API specs and a reference application. At the moment, we have all kinds of sources of information and stuff, and we have, for instance, the glossary of terms published on the DCSA website. We have process diagrams that are created with BPMN, but most of them are made in PowerPoint. We have an information model, entity relation diagram, a big entity relation diagram that's modeled in EA. Then we have some use cases, some state charts, and some activity diagrams in EA, and they're published in Word. And at the end, we have an API that is a REST API, and it's published on Swagger. And you can imagine that describing a digital standard in this way is quite cumbersome because maintainability is hard. You have to change something somewhere and make it consistent in the other sources as well. There's hardly any traceability and consistency over the sources, and it's very difficult to take into account the versioning of API releases. So what do we want to see in the future? We like to overcome the growing complexity. I already said there are many parties involved, so you can imagine that creating a standard when many parties are involved, it's getting quite complex. So instead of writing documents and just making API definitions is not enough. So we move to model-based system engineering. Instead of making a PowerPoint diagram, we are going to annotate the diagrams. So we're annotating the diagrams and the model elements. We want to do it in an iterative manner with quarterly publications of the previous versions and the new versions of the API descriptions. We want to publicize it on a web portal, and in that model repository, which will become the single source of truth, we want to have drill down and traceability. So that's what we want to see in the future and what we are aiming at the moment. So this is what we want to achieve. We provide a context for the standard so that business analysts can understand it from a business perspective. Solutions architects can understand it from a data and interfaces perspective. Developers can understand the business context as well as the implementation directives. Testers can understand the business context, the data, and can create worthwhile test cases. And the in-house developers used all the information that's gathered during the design process to create a reference implementation. And by doing so, we prove that the models and the implementation are correct and complete, all the way down from process, data to implementation. And by putting everything in one single repository, we reduce the maintenance work. It all started with this whiteboard in which all kinds of levels of modeling and implementations are brought together, and that forms the Industry Blueprint 2.0 project. We integrate all these diagrams and models into a process that can make API development possible. It's very important for non-modelers to understand that a set of diagrams is not a model. So that means that you have to make diagrams made of elements and relationships with descriptions and put them into a model. And for people that don't do modeling, modeling is pretty tough when you start with it. So one of my goals, my personal goals, was to make modeling fun and also easier to do. I transferred that whiteboard drawing into a first kind of a model in which we show what we're going to do. In the dark gray part, you see all kinds of models, like a conceptual data model, a physical data model, a use case model, state transitions model, activity models. In the light gray area, you see API specifications. In the below that, you see the reference implementation, and below that, the test implementation and application implementation by the application developers. On the right-hand side, you see which part of the model we are going to put in Sparx and which part we are going to put in Prolaborate. How do we do that? First of all, we are going to make a lot of different diagrams and models, and we like to connect them to make a better understanding of all the separate parts of it. So lineage between all kinds of model elements in all kinds of modeling notations is important. At the top level, when we start a new project, we think about the glossary of terms. As I said before, everybody has to speak the same language if they are involved in developing this API. And that means that we start with a glossary of terms that we link to process models, and information and data models. How we do that, I will show you in a minute. Process models and information models will be the starting point for design models, like use cases and activities, etc. And at the end, we would like to create the open API specification based on what we have modeled. And we're going to do that also will explain. And based on that open API specification and those Java transfer objects, we can create the implementations that we require. So we start with process modeling. If there's nothing, you have to start somewhere, and to get an idea of the industry or the part that you want to automate or provide a data exchange layer to is very important. So the first thing is to make a process model in a standardized way. And that means that we make processes easy to understand. If you look at BPMN, it's a use not a modeling notation, but we only use part of it. That part that is required to understand, easily understand how the process works. So we create diagrams and models that are easy to create and are easy to discuss. Then we verify that for completeness and accurateness. And then by doing so, it's very important that you don't start with an empty sheet. How we achieve that, I will explain later. In the past, when we created APIs, we found out that during implementation, we all got stuck somewhere because there were all kinds of exceptions that we didn't discuss or didn't find while doing analysis. And that means that APIs are postponed because the reference implementation is very difficult to create, because all kinds of exceptions, which might be on process level, functional process level, were forgotten. So to overcome that problem, I introduced another methodology called enterprise engineering, which is demo 4, which is done by one of the partners of eXpertise as a modeling notation. And I combined that into a standard pattern. So I used the ideas of the demo 4 process modeling and put it in BPMN, because I think for now BPMN is a much easier way to understand process modeling. And in this diagram, which looks very difficult in the beginning, maybe, is shows the transaction pattern. And the interesting thing is that each transaction between two parties, that's important, there are two parties involved. One is the initiator, one is the executor. And when that happens, there are 3 stages that a process will go through. So a transaction is finished after passing 3 stages. It can be stopped in an earlier stage, however. In the order phase, which is the left part, you see that it starts at the top by requesting something. If you request the dollar something in this slide with something like ordering pizza, and you'll immediately understand what's going to happen. So that means that if you order something, you can have the situation that, okay, the executor is not able to do that. So he first is going to verify what you are requesting. Can I solve that problem? If not, I can say, well, sorry, I cannot do that. And then the transaction will not even start. If I can create the thing, if I can create a pizza, then I can say, okay, I'm going to make the pizza, and it will cost you, say, 25 euros. And then as the initiator, you can say, wow, 25 euros is too much. I don't like that. Can you make it 20 euros? And I can say, well, I don't do it, but I promise that I can do it for 25 euros. If you accept, then I have to go to the kitchen and prepare the pizza. So that's done in the execution phase. At that moment, I'm going to provide the stuff that I've promised to provide. If the pizza is ready, then I say, okay, dear initiator, I declare this pizza ready, and I provide it to you. And you look at the pizza and you say, well, it's still rare. It's not, the dough is not good. All kinds of stuff is not good. And then you can reject you can reject the pizza. And then I can say, I can look at the pizza and, oh yeah, I have to cook it for 2 more minutes, and I put it back in the oven, and I declare it ready after 2 minutes. If the pizza is acceptable, then you accept this pizza, and then the process stops. And you see, there's a lot of communication going on between the two parties during this process. And if you don't take this into account and you only think about one of the transactions because that's the API you were thinking of, you forget all kinds of exceptions at the functional level. The nice thing about this pattern is that it always works when two parties are involved in a transaction. If there are 3 parties involved, say, I'm not going to create that pizza, but somebody else is going to do it for me in the kitchen, then it might be that this pattern is part of the execute as well. So you get a kind of stacked transaction. The core concept of this standard process is that there must be 2 parties involved and not systems. So you talk on a personal level. The transaction initiated by somebody and is executed by somebody else. And order and result phase can stop the transaction whenever possible or required. So both initiator and executor have their responsibilities. I'm not going into details in the theory behind this, but I find it very interesting way to model business processes because you can you don't have to start with a blank sheet. And if you want to have business analysts going and knowing that you want to create an API, then it's important that they don't start with a blank sheet. So this is a nice template to start with if you're going to model the situation in which a transaction is involved. Yeah, so exceptions at functional level are very important to understand and therefore require more detail. As I said already, all those pink circles are messages that are exchanged between parties. And that means that probably each intermediate event, as it is modeled in this BPMN diagram, is an API call. Can be maybe combined to one call, but it's most likely that they involve several API calls. So the intermediate event in a business process diagram is for us very important to understand what's going on. And this morning I listened to Jacek's presentation in which he said, if you want to model something, use one modeling notation always. And I know that a lot of modeling tools use that principle. But the most interesting thing I like about Sparx Enterprise Architect is that it uses, or you can use more modeling notations in the same diagram. And that's what and for me, that's very helpful because it makes it possible to go from one modeling domain to another modeling domain. For instance, to the data modeling domain. I hope you all know about data. If you're involved in data management, you probably know about the data management body of knowledge. And for me, the most important part is the thing that you have to start with. If you look to this circle as a clock, you have to start with data modeling and design. So data modeling and design, besides process modeling, is very important to make a standard work. Because you can talk about the process, but you also have to talk about the information that is exchanged between processes, or at least between parties involved in processes. According to Dama, data modeling is important because it provides a common vocabulary around data. It captures and documents explicit knowledge about an organization's data and systems. It serves as a primary source of communication during projects, and it provides a starting point for customization, integration, and even replacement of an application. These are all applicable at DCSA as well, and I included the fact that it also helps in data exchange between systems. So when we are modeling data, we model it in 3 different levels. We model it in a conceptual level, in a logical level, and a physical level. And for each model, we define the scope, and we make sure that the models we make are retained in documentation. An example of a conceptual model, if you type in what's a conceptual data model, and ChatGPT provides you this answer, it says that conceptual data model is the first and most important step in the data modeling process. So that helps. How does it look? What I came up with is that we have the glossary of terms, and I put those glossary in terms in argument business objects. And while modeling, you can create new elements as well, new terms as well. In this example, booking and shipment are 2 terms in this in the already existing glossary of terms. And while modeling, I came up with some other terms which are still in capitalized letters. The interesting thing is when you put this in model, you can also not only use the terms as modeling elements, but also the relationships between those terms. So basically what you do is you add value to the glossary of terms by relating the terms with each other. A logical data model is, as you might know, a set of entities and attributes and relationships between them. And here I have an example of that. In the diagram below, you see a logical data model of a part of our huge data model. And what's important is that all the, or at least most of the attributes of an entity come from somewhere else. So in the white diagram, you see that the yellow boxes are terms that are in the glossary of terms. And I've linked those terms to one of the logical data elements, in this case, transport document, and related the attributes to those terms to see if all the elements from the transport, all the attributes in the transport document have an origin somewhere. So I came up with the fact that I miss the vessel call sign in this case in this transport document entity. And that's why I painted it orange. But as I found out in further discussions is that this glossary of terms item is not used in the logical data model, which is a bit weird, I have to admit, because the vessel call sign is the only really unique identifier for a ship. Anyhow, then we go to the physical data model. And because we are making two things at DCSA, one is the API and the other is the reference application, we can use two different physical data models to create, on one hand, the API, on the other hand, the database for the reference implementation. Here you see the physical data model for our reference implementation. And I haven't shown it here, but I can, of course, link those attributes towards my logical data model. So I can see that a physical data element is exactly the same as a logical data element. I can also provide scripts to transfer or convert one type of entity to another type of data entity. And the REST API is also being modeled. And that looks a bit different than the database model. Here you see in the blue part of the diagram, you see the API data elements, which will be put in JSON or generated to JSON. And here you see the mapping between those attributes and the attributes in the logical data model, which is in the yellow part of this diagram. Going back from to the starting point, so we start with a glossary of terms. In this case, I use the business objects, argument business objects for it. And the interesting thing is, if you have imported this, you can use them in the glossary of terms list. So they will appear in the glossary of terms inside EA. And that means that if you go to a notes field and a term is found in the text string, a pop-up will show what the actual meaning of this term is, which is very helpful. But the other nice thing is that if you put it in the glossary of terms items in EA this way, you can also make a query that you can hand over to Prolaborate and show that glossary of terms as a list in Prolaborate. And that makes it a maintainable list. That's interesting. Here I showed traceability between the conceptual data model, the logical data model, and the physical data model. In this case, two physical data models, which are in the blue parts and the bottom. The logical data model is in the green part, and the yellow part shows the conceptual data models elements. So here we have done modeling all kinds of data stuff, and now we're going back to the process models to see how we can make those intermediate events usable in other model parts. As I said before, the intermediate events say something about interaction between two parties, and that's at the functional level. So it holds two things: the interaction pattern at that point, which we describe in a use case, and below a use case maybe in sequence diagrams, etc. But I also to come from a business process model to a use case model, which is the next step in the analysis process, we connect all intermediate events that pass a boundary between two parties. We attach a use case to it, and from there we can drill down in what's happening at that very point in the interaction between those two parties. Besides that, you can imagine that when you move a container, for instance, you have all kinds of states and state transitions. For instance, if this is the model of a booking, so you can imagine that if you want to book a container You can have the situation that the booking is cancelled, that the booking is rejected, that the booking is confirmed, that the booking is completed, etc., etc. Those are states in the process, which you won't find in the process diagram, in the business process diagram. But the interesting thing about these kinds of diagrams and combining this with the use cases that you also have created in the, or first created in the business process diagrams, you find that those use cases say something about the transition between two states. And sometimes a use case is involved in multiple transitions, going from one state to several other states. But most of the times they are involved in only one state transition. So in this diagram, you see that there are a number of state transitions that don't have a use case. That means that or we have forgotten to write them down, or we haven't modeled our business process well enough because the cancel state, for instance, is not dealt with. And interestingly enough, while knowing that a use case is involved in a state transition, the pre and post conditions of that use case are states. So a use case starts in one stage, that's the precondition, and ends in another state, which is the post condition. And by doing so, you can see if your state transition diagram is correct, or that you have all the use cases defined, and maybe if use cases are missing, you have to see if they are missing because something is missing in the BPMN diagrams. So the linking pin between the business processes and the use cases is the information and the intermediate event. And the use case describes one or more interactions between the parties involved, the applications involved, and that means that for each interaction we can make a REST API call. So here you see that in the definition of the booking process, we have 4 use cases that use 3 of those API calls. I use the Open API interface class, which I found by using, which I started using by using the Integra Open API plugin. There are some tools that help you generate Open API specifications. I will come to that later. The best way, in my opinion, the best way to express how an API works is by creating a sequence diagram. And interestingly enough, when you model the API as an interface class and you have a port, you can use that port on a sequence diagram. So the nice thing about sequence diagrams in Sparx is that I don't have to use those predetermined objects that you can use in a sequence diagram. You can use everything, every model element you can use in a sequence diagram. So here I use the carrier application component and the interface class and an actor in one diagram. Oh, and by the way, the booking on the right-hand side of the sequence diagram is a data class. And you can see that all the interaction is there. And I reuse data elements in that interaction as a parameter. So here, which in this way, I can create a proven sequence diagram. That was version 1. In version 2, we come up with an even better solution. Here you see an Open API interface class, and with the Integra plugin, you can see on the right-hand side of this diagram, you can see on the screenshot, you can see that you can fill in all kinds of Open API information. like the title, the version, the schemes used, the security used, etc., etc. And that I can model in open API interface, the get and the post, and the patch and all those REST API calls. So in this diagram, you see that the intermediate event arrival notice issued belongs to a use case called send arrival notice, and that uses the arrival notice data elements. You see, if you double click on arrival notice, you'll see what it entails. And on the left side, you see that there are two applications involved by the implementation and usage of this open API interface. So this in itself is a very explanatory, self-explaining diagram. The interesting thing is, as I said before, you can use all kinds of element types in the sequence diagram. Is that on the left side, I use the conceptual data model element vessel in this diagram to show that when it arrives at a port, the carrier application, which is responsible for the arrival, will know about that and will prepare the notification to that arrival of that vessel, and will send an arrival notice event to the notifying party. The notifying party can use the open API to collect the data about this arrival notice, which is a large data model that's behind that. The interesting thing is about when you model this way and you start to use introduce the messages, you can reuse that those messages from the operators that you have created in the definition of the Open API interface class. And at the end, you can generate an Open API specification for the Swagger Hub page, for instance. Open API generation might be very interesting. It was quite a quest to find something that is useful. I came up with two plugins. The Integra plugin from integra.com in Poland, which I used for this demonstration. And I know that the last presentation in this EA Global Summit cycle is done by Edgardo, and he also has made a plugin for creating open API specifications. So that might be very interesting to listen to as well. I'm not sure, maybe there are other plugins that do similar things, but what they should do is generate and read open API specifications. The other part is, okay, we have made all kinds of nice diagrams and models and stuff, and there's a lot of NDA going on, and now we have to put it to publish it to our stakeholders. In the past, we had to create documents, publish documents, put PDF, create PDF documents with process diagrams, maybe written in, maybe designed with PowerPoint, put it all, bundle it all together, and all the stakeholders had to find out that the information was probably not that consistent. We try to overcome that by putting it in Prolaborate and review as we go. So that means that we can become more iterative with our stakeholders. Because we do it in Prolaborate, we always sure that we have our work in progress repository is always as up to date as possible. It only shows the information that is fit for publication, because we can hide parts of our model that are not targeted to the audience already. And we establish quarterly publications of this standard. So we have a work in progress, development, design and development, and a final standard. So for each final standard, we have our own access point to show that to the stakeholders. And how does it look? When we're working with in the working in progress state, we create these kinds of dashboards in which our subject matter experts and stakeholders can have a look and see what is missing. So we show all kinds of varied diagrams. We describe what each diagram does. We have drill down functionality. For instance, in the diagram, in the lowest, the top, the bottom left corner, you see there's a port element or a vessel element with an infinity symbol, which means that if you double click on that, you go to a more detailed diagram there. So we have more or less automatic navigation. We show the process model. We show the use case model. We show the logical data model. And what's important, we found out what's important is when you're going to implement data in a data exchange situation, like your open API, not all attributes are required to fill in. When you do a get, for instance, maybe you only need a unique number that's shown here. And for each use case, we are creating such a diagram, and we use requirement symbols in between to see if attributes are being used in that use case or API call and are required, optional, or conditional. I've talked about this diagram already, and I talked about this diagram already. So this is what we are showing to our stakeholders via a Prolaborate dashboard. And it ends, of course, with a link to the Open API specification of a certain standard. But besides publication of the contents of your model, it's also possible to export part of your models. So, for instance, if another stakeholder is using BPMN, for instance, to make their own models, we can provide our models to them, and they can use it in their modeling as well. Or we can provide a link to our dashboard for their use, so that you can imagine that I have maybe some Confluence pages somewhere, and can link into and they can link into our real-time models as well. Well, it has some implications, because as I said before, not everybody is a very good modeler in the beginning, and we have to provide sufficient information for an interface. You have to put a lot of information into a model, so that means that we have to put in more information in models. We have to spend more time in Sparx. We also need some automation script development, because it's very handy, for instance, to convert a logical data element into a physical data element, which means that I can have attribute-to-attribute mappings, and all the notes and descriptions that I've added in, for instance, a logical data model, is automatically put into the physical data model. We can do model validation, so I can write scripts that say, okay, I have a state transition diagram with 17 states, and 2 states of them, state transitions of them are not connected to a use case. So I can write all kinds of validations for that. It also means that we're not drawing diagrams with empty boxes, but every box should have the nodes filled, and each diagram should have nodes filled. And of course, to do a nice way of modeling, we need meta models and guidelines. So at the moment, I spend a lot of time helping out people starting to do this. Of course, we need support of the tool. So that means that for for various types of modelers, we have to change the look and feel of EA a bit. So we need to do some tuning of the user interface. A dashboard is a nice thing to have in Prolaborate, but when the standard is set, well, we expect that when the standard is set, it's just part of the overall repository model. So that means that we will probably get rid of the dashboard, but start using navigation inside our repository in a better way. What we like to achieve is that we can forward and reverse engineering of open APIs, and we do a lot of scripting. So for now, that's my presentation. If you're in the container industry, you're most welcome to join us at DCSA or get in contact with us at DCSA. My product owner is Gerard Meijer. He's the subject matter expert in the industry blueprint. If it's DCSA related, you can contact me at DCSA. And if it's EA related, please use my EA expertise email address. So that's what I wanted to talk about. Thank you very much.
Thank you, Anne. Thank you for your wonderful presentation. We have some interesting questions from Slack. I'll read out a few.
Okay.
So we have a question from Robert. Are these findings shareable as templates, something like the APM one?
Yes. I am working on creating a number of templates based on what I've done the last couple of months at DCSA. So they are not yet there yet, but I can imagine that in a matter of months, I have a number of templates available that will help you model these kinds of diagrams. Yeah, and a lot of scripts that help you make your life a bit easier. Yeah. But for now,
so,
that's not enough.
We have another. Sorry.
Yeah, please.
Yeah, we have another question from Kevin. Yeah. How long did it take to train everyone in the client side to use this approach?
Interestingly enough, I like to come up with the normal IT answer in this case. It depends. We had a very young, enthusiastic Italian working on the process modeling, and he had no prior EA knowledge at all. So I learned him using EA in a couple of hours, and then he went off and changed all kinds of process models in a good way. So that was pretty easy. The most difficult thing I can imagine that we will head to is the fact that developers happen to be the worst modelers of all kinds. This probably not applies to everybody, but what I notice is there's quite a resistance between developers using Open API specifications and the Swagger editor to create the Open API specification. And because they say, well, I can do everything with a keyboard and I don't need models. I think those are the people that will take the most amount of time to learn to use EA and make them aware of the fact that lineage inside, traceability inside a model is very important to have, especially when you come up with a standard in which you have to prove that each attribute, each data thing, whatever is coming from somewhere. I think that will take the most time. But I also work with people that are in between, so they're business analysts And I find that if you have a nice approach, or this nice approach, it will take a couple of hours to make them sufficiently good enough to use use EA. But I have to admit that I have to help them to set up a good workspace in EA, because a workspace in EA is very important, I found out. And the default workspace in EA is a lousy one. So you have to change that. And that makes it exception of EA much easier, I noticed. Okay.
Yeah. Since we are running out of time, I request you to complete few more questions post the session in Slack. Han.
I will go there. Thank you very much,
Yeah.
Gavi. Thank you very
Thank
much, everybody, for joining in.
Thank you, Anne, for sharing your valuable insights. I also
Thank you
want
very
to
much.
acknowledge the active participation and engagement of our audience. Thanks, everyone. If you have any questions or want to delve deeper into this topic, we have set up a dedicated Slack channel for you. This is your opportunity to connect directly with Anne, share your thoughts, and engage in meaningful discussions. If you still need to join the meeting room in Slack, please join Slack through the link provided in chat box. Our speaker is eager to continue the discussion and answer your question. So don't hesitate to jump in and make the most of this opportunity in Slack's meeting room. Thank you once again for your active participation, and I look forward to seeing you in the Slack channel. And of course, in future sessions throughout the summit. Thanks to all.